Hello guys, so first off, today we did our project P2 of ENGI 1331 on industrial analysis. So industrial analysis is basically a way to solve problems due to specific limitations that you're given. So most of the times we're going to run into different problems where we have to find whether or not we make a profit or whether or not we don't make a profit based on certain limitations that are set from the problem. So we try our best to find the optimal solution. So industrial analysis is the process of determining the best product mix to make a maximum profit given a certain set of equipment. So it also includes a review of different factors that may affect how a product sells, such as the economy, competitors, and that may show up. This process is necessary because being cost efficient can help a business in the long run. So within this problem is that we use two different methods, which is the traditional and the bottleneck method. So the traditional method assumes that all demands are met and is basically defined as the total production cost of a unit subtracted from the selling price. And then from the result, the products are ranked accordingly. And then the second method is the bottleneck method, which calculates the profit for a certain product over a certain time interval and then displays the ranks accordingly once again. So first off, we'll go on into the code, which I will briefly describe each of the algorithms and the steps we followed. So first off, we have our housekeeping commands at the top. And then we go on to part one, which is data input and validation. And task one, we ask them to input the company name and the number of weeks that it works yearly. And then we make sure to check that the length is no greater than 2 and that the weeks are within 0 and 52 weeks in a year. And we make sure that it is a length of 2 cell array. Then we go on to task 2, which is product name input and further data validation, which we ask the user to input product names and make sure that their input has to have at least something within the cell array, and that it is in row vector cell array format instead of a column vector format. Then we go on to machine names and data validation, and we ask them to input machine names and make sure once again that each machine name, that there is something within the machine name cell array that they inputted, and make sure that once again it is a row instead of a column. Then we go on to machine availability, where we go through each machine name, which keeps it consistent and make sure that we have the machine availability for each different machine instead of abstractly getting different machines. So this keeps it from hard coding and keeps it consistent. So we ask them how many hours per week is available, and then they will input it, and they will input and store it within a matrix. Then we go on to task 5, which is data collection. So we start off by initially analyzing a vector, an empty vector, and then we go through each product name through each machine name to make sure we keep consistent with the number of products and the number of machines. And we ask how many hours for the specific machine does the specific product require. Then we go through and ask for the material cost, the labor cost, the selling price, and the demand per month. And then we store all those within its specific variables, and then we'll display, and then we'll all store the whole thing into a big matrix called cost, which holds the material cost in the first column, labor cost in the second, selling price in the third, and demand in the fourth. So now we go on to part 2, which is calculations, and task 6, conversion. So first we make sure we get the yearly demand, so they have inputted the demand in months, demand per month, and then we're calculating the yearly demand and we're storing that in YD. Then we have machine availability yearly, where we calculate how many hours that a machine can work in a whole year, since it's based off how many weeks that you input at the very beginning and how long the machine works per month. So then we go on to contribution margins, where we basically get the contribution unit first, which is the selling price minus the labor cost and the material cost. Then we calculate the contribution margins for each specific contribution unit, and then we display and let the user know that the contribution margins have been calculated. Then we go on to part 3, which is combining data. So first off, we will combine all the data together, which includes the machine hours. Then we have the material cost, labor cost, selling price, demand, and lastly on the last row is the contribution margins, which will change for a different method, which for now we are on the traditional method. And then we will display that the data has been combined, let the user know about that. Then we go on to part 4, which is the traditional method. So task 9. So with the traditional method function, where it goes sends the product name vector and the combined matrix into the sorting, and then the sorting will take the size, and then it'll go through all of combined and sort them into descending order. Then it will output a total data with the product names on the very left and the rest of combined on the right next to it, and with the data for each product on that same row. Then we'll go on to task 10, which is finding the traditional methods product mix and bottleneck. So first off, we take the size of total data, then we make sure that we get the matrix without the names, and then we go through and find which is the bottleneck machine. Then we go into the while loop, which basically calculates the amount of units for each different product that it could be produced in that year. And then just in case, if say for the one of the products already instantly clears out all the hours for one machine, then the rest of the products that will not be produced, since the machine can no longer produce anymore, it will make sure that each product after that will display zeros, so it can show that, oh, product 2 could not produce anything, so it had 0 units and 0 contribution. Then we go on to task 11, which we find the traditional net profit from the traditional method, and we display the profit from the traditional method, and then if it's under 0, then we'll tell them that the net profit is currently negative. Then we go on to task 12, which is the bottleneck method, and using the sorting function again. And so we go in and we get the bottleneck machine, and we find the profit margin time, and then we create a new combined with project profit margin time on the very last column instead of contribution margin. Then we go ahead and do task 13 like we did task 10, and we calculate all the product mix, including each of the things required for the bottleneck method, and we will display it in order of the demand, which is whichever has the greater profit margin time, and whichever creates a better profit in general due to the limitations, which is what the bottleneck method does. Then we go on to task 14, which is the bottleneck net profit, which it will find the total net profit that is gained from the bottleneck method, which is different from the traditional method. Then we go on to part 6, which is we are exporting and combining all the data. So here we just combine the data into a one big matrix of sort, and then we Excel it, and then we write it, and then we close it. And then, so now we will move on to, and I'll run my code now and show you how the code works. Okay, so first I run the code, and then instantly it'll first ask me to input the name of the company and how many weeks does it operate. So for say, let's first off, like, I don't input anything. So here comes the data validation, tells me that I did not correctly input a name or the weeks, so it's asking me to restart, which is asking me to re-input value. So first off, we're going to put in Cougar Company and 50. So then it would go on to ask me the names of each product. So in our case, we're gonna use 2 products, which is blankets and scarves. But let's say for the next one where it asks us for machine names, I don't input anything. You will see the data validation comes in and asks that you did not provide any data, and it asks us to restart again. So then here again, we will restart the code and redo it. So once again, we're going to input Cougar Company and 50. Then we will input the names of each product, blankets and scarves. Then we'll input the names of each machine, which is machine 1 and machine 2. Then we will go on to how many hours per week is machine 1 available, which is 40, and machine 2 is 40. And how many hours does machine 1 do each product? So that's 2 for blankets, and then for machine 2 is 1 for blankets 2. And then the material cost is 30, the labor cost is 20, the selling price is 70, and the demand per month is 70. And then the machine hours for machine 1 for scarves is 0.5, 0.25 for machine 2, $5 for material cost, $9 for labor cost, $25 for selling price, and 120 scarves demand per month. Then it would display that the conversions have been completed, the contribution margins have been calculated for each product, and the data has been combined. And then it will display the total data for the first traditional method, where it ranks the one with the highest contribution margin to the lowest contribution margin, which blankets is first and scarves is second. And then we input the fixed cost, which and then produces that the net profit of the traditional method is $18.8840, and then it will go on to calculate the bottleneck method and then display once again that the products in order through the bottleneck method, which in this case that now scarves is ranked 1 and blankets is ranked 2nd. And as you can see on the right side, that the bottleneck method on the very last column is now 22 and 10, which is the profit margin time. Then it will display the net profit using the bottleneck method is 23,640. So all in all, that is the end of the code. And another thing I want to talk about is that there are certain limitations in the code in that look at how many inputs that you have to input. And once you input one wrong, it could completely turn everything in the code completely wrong. So we have to be very careful, and it's very tedious on inputting what you specifically need. And once you mess up, it could cause you to restart the whole entire thing, which can take a little bit of time, which is some certain aspects of limitation. And then application is that engineers and other different majors can also use this method to help them problem solve for profits, and especially ones that are working with a budget and specific limitations. Then this method could easily help you figure out profits in 2 different types of methods, and it's really helpful for each person. Then that all in all, that is it. Thank you and goodbye.